Hello, everybody. So we are looking at an introduction to inequalities today. So, excuse me. First of all, the word inequality, what does it mean? Yeah, it really just means inequality means not equal to. Inequality. So we're not using an equal sign here. We're using an inequality symbol. So there are a few of them. Here they are. You have that one, that one, that one, that one, and there's one more. Well, an equal sign with a slash through it. So what do all these mean? So the symbol right here, if you read it out loud, you read it as... Well, it's confusing when there's not things on both sides. Let's say I had 3, this symbol, and then 5. How do you say that out loud? 3 is less than 5. Right. So basically, I don't know how you learned it, but you probably learned it at some point. If you turn this thing into a Pac-Man or an alligator or whatever, he's going to eat the bigger number. So whichever number is bigger, the mouth is going to eat it. Maybe you learned it alligator, Pac-Man, I don't know. Usually that's what someone does something with that, and then the mouth is just going to eat the bigger number. So if you read this out loud, it would be 3 is greater. Oh gosh, 4 a.m. Remember, okay? It's been something. 3 is less than 5, right? Now, you can also read this backwards, and that's going to be helpful to come into play later. You can read it backwards as 5 is greater than 3. So in other words, I can literally just flip this right around. 5 is greater than 3. These two things right here, this and this, mean the exact same thing. They're just flipped over. Do you see that? Does everybody see that? So you can say 3 is less than 5 or 5 is greater than 3. They both have the exact same meaning. So, what's the deal with these things with the line underneath it? Greater than or equal to. Okay, so that's like saying, if you're at the grocery store and there's a great deal and the limit is, over the weekend, there was 99-cent cereal. Yes, it was Cinnamon Toast Crunch, Lucky Charms, or what's the third one? I can't remember. It was something I didn't like, so I didn't get it. So, anyway, the limit was 3. So you could either buy 1 box, 2 boxes, or 3 boxes. You don't have to buy all 3. You could just buy 1, you could buy 2, or you could buy 3. So the limit was, well, you could buy any amount less than or equal to 3. Okay, so X would be the number of boxes of cereal I bought. You could buy anything less than or equal to 3. You were allowed to buy 3, but you couldn't buy any more than that. But I could also buy 1 or 2 or none if I don't particularly like cereal.
Could you only buy 3?
For that price, yes. So for the sale price, you could only get up to 3. So that's the difference. If they had said, which I've never seen this in a sale, so it'd be kind of weird, if they said you had to spend less than, or buy less than 3 boxes, which would be weird. Why would they ever do that? They wouldn't. So, oh, you know what they do though? They double coupons up to $1, but not including.
That's crazy.
Yes. So if the value of your coupon is less than $1, it will double. Yes. Oh, yes. So a 99-cent, which would be, amazing if you found one, because they're mostly either 50 cents, 25 cents, 75 cents if you're lucky. But yeah, Big Y, Stop and Shop, Shaw's, Big Bunny. I think Big Bunny. I'd have to double check. But almost all of them double coupons that are less than $1. Occasionally you'll find a coupon that says right on it, do not double. Then those won't, but all the other ones will. Oh, it's so great. So there's an example of not having the bar underneath it, because I can't, if my coupon's $1, it's not going to double. But if it's anything less than that, 99 cents, 98 cents, sure, it'll double. Okay, and then what's the deal with this last thing. Have you even seen this last symbol before?
The interruption. All students who signed up for the QCC and STCC stick, please report to the auditorium.
They're colleges.
QCC and stick meetings in the auditorium and
Okay, this last symbol is literally just not equal to. Guys, are you listening? So it's just any number that's not equal to the one that I said. So for example, I don't know, say we were playing a game and you had to roll a die and you're going to win as long as you don't roll a 5. I could write it like this. As long as X, your roll, does not equal 5, you win. Something like that. So it could be any other number, just not 5. That's what that symbol means. It could be bigger, could be smaller, doesn't matter. Just can't be 5. So far does all this make sense? Have you guys seen these symbols, maybe besides this one before? Greater than, less than? Yeah? Okay, good. So now we want to be able to graph these numbers. If I said give me a number that's less than 7, how many numbers are there less than 7?
Wait. Are we counting negative?
If I just say give me a number less than 7.
A lot.
64.
There is an infinite number of numbers less than 7. Because you can have negatives. You could also have decimals. You could have 6.99, 6.98, 6.998, 6.99998. There's an infinite number of numbers less than 7. So, guys, how do I show them all on a graph? It's actually not that hard. If I want to show all the values that are less than 7, and I look at a number line, right? So let's just throw some numbers on here. 0, 5, 10, 15. Okay, so 7 would be right about here. If I want to show, oh geez, you can't even see. If I want to show you all the numbers less than 7, guys, are you paying attention?
Yeah.
Here's what I do. If my symbol is a greater than or less than sign and it does not have the bar underneath it, when I go to put the dot on the 7, do you know what I do? You got to keep it open. That open circle means that you can have everything up to 7, but not including 7 itself. And then I want to show all the numbers that are less than 7. So isn't that all these numbers? So usually we just kind of shade or darken, and then we put an arrow showing those are all the numbers that are less than 7 in the whole wide world. I don't have to list them. I just make that graph, and that graph shows all of them. Does that make sense? So, something important that you're going to want to mark down, if you have greater than or less than, you're going to use an open circle. If you have the line underneath it, you're going to use a filled in circle. I like to remember it this way. Making this line underneath uses more ink, so I have to use more ink to fill in my circle. And then I'm just going to shade the part of the graph that represents the numbers that I'm looking for. So, if I flip this paper over, let's see if we can try some. This first thing, I'm looking for a graph that shows me x is less than 2. So let me ask you this. Should the dot be filled in or not filled in?
Not filled in.
It should not be filled in. So I'm going to start off by looking at all these graphs, because I'm trying to match it up with the right one. I'm looking for someone that has an open circle on the 2. So it looks like the very first one does. So does this one. Okay, so it's got to be one of these two. How do you know so quickly?
I don't know.
Well, I want all the numbers less than 2. So does this top one show me all the numbers less than 2? No, these are the ones greater than 2. So T, yes, those are the ones that are less than 2. Does everybody see that? So number 1 matches up with graph T. Number 2, what am I looking for? What kind of a dot should be on the 2? An open one or a closed one? Closed, because it has the bar underneath. So I want to start off by looking for a closed dot on 2. So it's either A or W. And then I want all the numbers less than or equal to 2. So which one is that? Is that A or is that T? I mean W. A or W? W, right? Those are all the numbers less than 2. So 2 is a W. I'm going to give you a helpful hint. Are you ready? If your variable is first, the inequality symbol points in the direction that it should be going. So this one, I should not have, I want x is greater than 2. So I want 2 with an open circle. So it's got to be O, or I know we already used T, but pretend we hadn't yet. So I'm between O and T, and see how it's pointing this way, pointing to the right? That means that your line has to go to the right. So it's got to be O. However, that's only true when the variable is first. If we could just hop over to number 11 here, the variable is not first anymore. Yes, absolutely. So remember earlier we talked about just reading it backwards, flipping it over? If you're looking at 11, I would absolutely flip that over before I tried to do anything. It's so much easier to graph it when your variable is first. So instead of writing 1 is less than x, couldn't I just flop the whole thing over and say x is greater than 1? Isn't that the same thing? I want you to literally imagine like I picked it up and flipped it over. So now this is much easier to find the graph to. Just flop, like a page in a book. You took it and you flipped it. Now find me this graph over here. X is greater than 1. Which letter would that match up to? I have 1 vote for Y. Does anybody else agree with Y? I do too. I'm looking for an open dot at 1 because there's no bar underneath. So it's got to be M or Y. And then I want all the numbers greater than 1. So yes, I agree. Y. Now, how do we graph these weird ones like number 14? I want to graph any number that's not -1. So just not -1. What kind of a dot do you think would be at -1 if I can't have it? Open, right, because open says you can't include this number. So I'm looking for an open dot at -1. So let's see what my choices are. Oh, well, it's got to be R. But yeah, pretend I didn't have all these options. See how everything else is shaded except for -1? Do you see that? That's how you graph something like 14. X is not equal to -1. So 14 should be choice R. Okay? Is this all right?
Yeah.
Okay. So your homework is to just finish this.